Good morning and welcome back to Math 098. Last class we started talking about factoring trinomials. We were looking at AC grouping methods specifically. So we were looking at factoring trinomials whose leading coefficient is bigger than 1. We always keep in mind that no matter what, the very first step of factoring is always factor out your GCF. So once that GCF is factored out, then you can say, okay, what kind of a polynomial do I have? Do I have a trinomial whose leading coefficient is bigger than 1? Or do I have a trinomial whose leading coefficient is 1? And those are two different techniques. Not that you have to use two different techniques, but I think once you see the technique we'll use for the other kind of trinomial, you'll get why we split them up that way. Okay, at home, I asked you all to look at problems 2 and 3 from our notes. Let's look at those together and see how your work compares with mine. Let's check it out. We have negative 14x squared plus 46x minus 12. So the very first thing I'm going to do here is I'm going to look for a GCF. Immediately, my eyes go straight to this negative, right? Because I'm thinking, oh, shoot, I have a leading negative, so I definitely have to factor that out. The next thing my eyes go to is that I have 14, 46, 12, and these are all even numbers. So immediately I know I can factor out a 2. I can think about possibly factoring out a number that's greater than that, but consider that 14, the factors of 14, are 1 and 14 and 2 and 7. So the only other factors I'm looking at are either 7 or 14, and we know that 7 or 14 cannot go into 12. So right off the bat, I'm going to say, okay, my greatest common factor is a negative 2. So I'm going to factor that out first. Take each term in our trinomial and divide it by a negative 2. So that gives me a positive 7x squared, a negative 23x, and then a positive 6. Good morning, Kevin. Double check. Negative 14x squared, positive 46x, negative 12. I love it. So at this point, according to what we did last class, we're going to cover up our GCF, hold on to it. That way we don't forget it, but that way it's not distracting. So it's a nice little neat trick. We're going to cover that up. Okay, now because we have a trinomial where our leading coefficient is greater than 1, it's a 7, right? My A is 7, B is negative 23, and C is 6. So because of this, I recognize I'm going to use the AC grouping method. Let the name tell you the steps you're supposed to take. So we start off by multiplying A times C, 7 times 6. So 7 times 6, oops, let's try writing correctly, is equal to a positive 42. My goal is to find the combination of my factors to give me my B term, which is negative 23. Okay, so let's write out my factors of 42. I have 1 times 42. I have 2 times 21. I know 3 can go into 42, so it's 3 and 14. And I believe that's about it. Oh, nope, sorry, and then 6 and 7, of course. Cool. So here are all my factors of 42. I have a positive 42. Notice I want my result to be a negative 23. What that ends up telling us is that both of my factors have to be negative. That's the only way that when I multiply, I can get a positive number, but when I combine them through addition and subtraction, I get a negative result. Negative 1 times negative 42 is a positive 42. But when we combine these, negative 1 minus 42 is actually negative 43. So that's not going to work. We're looking for a negative 23. Negative 2 times a negative 21 is a positive 42. And then a negative 2 minus 21 is a negative 23. And guess what? We have just found the correct pair. So that takes care of our AC part. Next, we're going to go into this idea of grouping. But remember, we need 4 terms in order to factor by grouping. But I only have 3. So I'm going to take my middle term, and I'm going to replace it with the 2 that I found here, with my 2 factors. So I have 7x squared minus 2x minus 21x plus 6. You probably at some point were thinking, well, how does she know to just write x there? Well, remember, I'm rewriting the polynomial. I'm not changing the values, meaning 7x squared minus 23x plus 6 is the same as this expression, except I've broken up the negative 23x into two terms. So 7x squared minus 2x minus 21x plus 6 gives us the same polynomial, right? Negative 2x and another negative 21x is a negative 23x. So we actually didn't do anything other than rewrite it. So it's the same value. Now that I have four terms, I am ready to factor by grouping. We have a 7x squared minus a 2x. I heard x repeat itself, so I'm going to factor out my x. So we have 7x minus 2. And that's okay, Kayla. Sometimes it just takes practice going through this process. You find the factors of your AC, but you have to combine these to get B. So you have to find the factors that when you combine, you get B. So it's that whole process of making sure all of those things line up. Next, I'm going to look at negative 21x plus 6. I know that that negative sign is going to come down no matter what. But more than that, it's a leading negative. So negative 21x plus 6 implies that I can factor out a negative 3. So if I divide a negative 3 out of both of these, so negative 21x divided by negative 3 is a positive 7x. 6 divided by negative 3 is a negative 2. Now notice my 7x minus 2's are the same, so I'm going to factor that out. Bring down the x minus 3 in the second set of parentheses, right? Because we divided out the 7x minus 2's, which left us with the x minus 3. And then I'm going to reveal that I was covering our GCF, which is negative 2. So this GCF is going to move right down in front of my answer, and we can call it. Here is my final factored form. Done. So all of you at home, when you practice this, you should have found negative 2 times 7x minus 2 times x minus 3 as your factored form for negative 14x squared plus 46x minus 12. Okay. As always, you can do a check. Do a check. Make sure it works. That way you can be confident. And Patrick, no worries. It's just going to take practice making sure that everything goes well. So what I would advise to all of you is that if your product is positive, like when you multiply A times C, if that gives you a positive number, you can have two scenarios here. Your factors could both be positive or your factors could both be negative. What will tell you the sign is that B term. So in this case, we knew that we had a positive 42, but we wanted to combine them to get a negative 23. Well, there's only one way to do that. And it's if both of those factors are negative, okay? So negative times negative is a positive, but negative plus negative stays negative, okay? Keep that in mind. Let's look at number 3. We have 6p squared plus p minus 5. The first thing I'm going to look at is, do I have a GCF in this case? And I'm going to confidently say, no, I do not. So immediately I'm going to go into this process of AC grouping. Because my leading term, 6, is greater than 1. So I'm going to multiply my A, 6, and C, which is negative 5, and that's going to give me negative 30. And my goal is to find B, which is negative, oops, that is not true. Let me white this out real quick. Okay. My goal, which is B, is a positive 1. Remember, your goal will never be a variable. So be super careful. Your A, your B, your C, they're always going to be numerical values. A is 6, B is 1, C is a negative 5. So my goal is a positive 1. I'm going to write positive, the plus sign here, just so that you remember it's got to be a positive 1. Okay, so let's write down my factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6, and that covers all of my factors. Notice that I need to multiply these to give us a negative 30, but my combination, my combining of my two terms need to result in a positive. So what that implies is that my larger number needs to be positive and my smaller number needs to be negative. So negative 1 times 30 is negative 30, but negative 1 plus 30 is positive 29. Negative 2 times 15 is a negative 30, but negative 2 plus 15 is positive 13. See how we're not finding that 1 yet? We're not getting there yet. Negative 3 times 10 is a negative 30, but negative 3 plus 10 is a positive 7. Still not. Negative 5 times 6 is negative 30, and negative 5 plus 6 is positive 1. Check. So you always find the combination that's going to give you your B term, which is in this case a positive 1. All right, we go ahead and we move through the grouping process, which means we rewrite. So we have 6p squared minus, you know what? You could write minus 5p, then plus 6p, or you could write 6p, then minus 5p. What I'm going to do is I'm actually going to switch the order. I'm going to put the 6p next to the 6p squared. So we have plus 6p minus 5p minus 5. Do you see how nice that is? I just rearranged the order of those factors, making sure to keep the signs with that particular value so that it's easier to factor by grouping. It doesn't matter. You could write it the other way. I'm just going to choose to put 6p near the 6p squared and negative 5p near the negative 5. Cool. So now let's factor by grouping. We'll look at the first two terms and the last two terms. Out of the first two terms, 6p squared plus 6p, I don't know about you, but I heard 6p repeat itself. So 6p is my GCF. 6p squared divided by 6p is simply p. A positive 6p divided by 6p is a positive 1. Next, I'm going to bring down my negative sign. So we have negative 5p minus 5. I heard 5 repeat itself. So there's my GCF. Negative 5p divided by negative 5 is a positive p. Negative 5 divided by negative 5 is a positive 1. Now that I went from 4 terms to 2 terms, I'm almost done. I need to have my final answer as 1 term. So my factored form, I'm going to factor out my GCF of p plus 1, which leaves me with 6p minus 5. And there is your final answer. Excellent, excellent work. I want you all to keep practicing this until it becomes second nature. With all of these factoring techniques, it's going to be really, really important that you master them because you're not going to be successful in your next class unless you master these factoring techniques. When you all move into intermediate algebra, you're probably going to factor almost every single day, okay? Keep that in mind. You got to be a pro at this. So don't let this go to the wayside. This is incredibly important. Let's keep going. Your turn. Number 4. We have 45n to the second power plus 26n minus 8. I'm only going to give you 3 minutes. That's it. 3 minutes starting now. Okay, so this one tended to be just slightly I wouldn't say tricky per se, just more cumbersome in the fact that you have to, really explore all of the factors. So let me show you what I mean. First off, when we look at 45n squared plus 26n minus 8, we notice there's no GCF. So we're going to go right into this AC grouping process. Now, you'll notice that A is 45 and C is a negative 8. So when we have 45 times a negative 8, that's actually negative 360. I think once you saw that number, you might have thought, oh, shoot, there are going to be a lot of factors here. And there are. It's not a big deal, though. Remember that our goal is that B is equal to a positive 26. So we're looking for a combination of factors that add up to 26, right? Notice our AC is a negative 360. So one's positive, one number is negative. So for instance, we can write out the first one, 1 times 360, right? And we know that our larger number has to be positive, the lower number has to be negative. So this is going to give me 359, and that's way far away from where we want to be. So what we could do is literally list every single factor pair. So, and I don't mind doing that. I even wrote that on a separate sheet of paper. But what I'm going to recognize and what I'm going to urge you all to do is that notice the difference is so high that we really want to find factors closer to a combination of 26. So I'm going to check out, let's try 9 times 40, right? So we've got 9 times 40 where 9 is a negative. So negative 9 times 40 is a negative 360. Negative 9 plus 40 is a positive 31. So I'm actually pretty close. If I do the math, I notice that after 9, 360 is definitely divisible by 10. So 10 times 36, but keep in mind one of these has to be a negative and it'll be the smaller number. Negative 10 times 36 is negative 360, and then negative 10 plus 36 is a positive 26. So the one we were looking for is right here. So again, it's up to you to write all of the factored pairs. I did that here. See, we have 1 times 360, 2 times 180, 3 times 120, and so on and so forth. I wrote them all out, and we recognize that the negative 10 and the positive 36, that was the pair that would give us a positive 26. Having said that, let's rewrite. We have 45n squared minus 10n plus 36n minus 8. Remember, we're just replacing our b term with the two factors, the two values that we found here. And now I get to factor by grouping. So we're going to look at the first two terms and the last two terms. Out of the first two terms, I'm going to factor out a 5n, right? Numeric variable part. You have to look at both, not just one or the other. So we factor out a 5n. If I factor out a 5n, I'm left with 9n minus 2. Double check. 5n times 9n is 45n squared. 5n times negative 2 is a negative 10n. I love it. Next, we have a positive 36n minus 8. Notice that when we look at these two factors, yes, they're both even, so they're divisible by 2, but we have to find the greatest common factor. And in this case, it's a positive 4. Always bring that sign down. 4 is going to divide evenly into both of these terms, and that'll leave us with 9n minus 2. Double check. 36n minus 8. Lastly, we are going to factor our GCF, which is 9n minus 2, and that leaves us with our other factor of 5n plus 4. And there is your final answer. Excellent work, Noelia, on your progress through this problem. I am hopeful at this point that this makes sense. I know that the number of factor pairs was high, but you have paper, you have pencil, you have calculators, you have the tools at your disposal to run through this process and to find the correct pair. Don't give up on yourself, okay? Give yourself more credit. All right. So that essentially takes care of factoring trinomials whose leading coefficient is greater than 1. If you go back to your flow chart, you'll notice that there were two branches for trinomials, and I'm actually going to show you over here. There were two branches for trinomials, where one was that your leading coefficient was greater than 1, so you used AC grouping. The other is where your leading coefficient is equal to 1, so then you factor by trial and error. So this is what we're actually going to work on. And Doc, you're absolutely right. Slow and steady. Slow and steady. It's not a race. And I know that that's, I say that, and I know that tests are timed and things like that. But in the learning process, all of this is not a race, right? You're building the strength so that when you get to that competition, which is the assessment, you're ready to go and you can just flow right through it, right? That's the process. Cool. So let's take a look. So we're going to learn how to factor trinomials whose leading coefficient is actually equal to 1. So we're going to use the technique factor by trial and error. So remember that no matter what, we're always going to factor out a GCF from all 4 terms first. What I'd like you all to do is put your pens and pencils down. Do not write anything. And as always, if you're watching this at a later time, just simply watch the video and then pause right after to record exactly what I'm about to write down. Okay, we have x squared minus 5x minus 84. Notice that if I wanted to, I can make a note that A is 1, B is -5, and C is -84. Now, the cool thing about trial and error is that it looks very much like AC grouping. So our method here is trial and error, and we know that because it's a trinomial whose leading coefficient is 1. A is equal to 1. We're going to go through the same process of A times C. So we've got 1 times -84, which gives us -84. My goal is still to find a combination that will give us -5, our B term, right? So here's A and C, and we want to get our B, which is -5. So we're going to look at factors of -84. So we have our first 1 times 84. Remember, the larger term is going to be negative. Okay. Then we have 2 times 42. And then we can do 84 divided by 3. That's 3 and 28. We're getting there. 84 divided by 4. That's going to give us 4 and 21. We're almost there. Let's try 6. 84 divided by 6. That's going to give us 6 and 14. And then let's try 8. 8 divided by 80. Nope, that won't work. So we've got 6 and 14. Aha. So we have 7 and 12. Very nice. So we're going to stop right there. The larger factors are always going to be negative. And then let's combine these and see what happens. So we know for a fact 1 minus 84, that's -83. That's definitely nowhere near where we need. We can run through each of these, and I will just to show you. So 2 minus 42, -40. 3 minus 28, that's going to give me -25. We have 4 minus 21, that's going to give us a -17, of course. 6 minus 14, that's a -8. So we're getting closer. None of these are working, none of those pairs. And then 7 minus 12 is a -5, and that's the one we are looking for. So this whole first process starts off the same in the way we ran through AC grouping method. But check this out. Once you have found your pairs through trial and error, we're simply going to write out our factored answer. We don't have to rewrite as a 4-term polynomial. We're going to go ahead and write out our sets of parentheses. Remember, we're just writing our factored form. Our first term is x squared. So wouldn't it make sense that in each of these parentheses, to get x squared, I have to take x and multiply it by x? So I'm going to break down x squared in this way. X times x is x squared. Now check this out. My factors were a +7 and a -12. Okay, so +7 and -12. And I'm done. I just finished factoring. I can use this factoring by trial and error method only when my leading coefficient is 1. Now, I say that because if your leading coefficient is greater than 1, then factoring by trial and error tends to be a lot more tricky than just using AC grouping. So my advice is to split them up in that way, okay? Not that you can't. So listen to me very clearly. You can use AC grouping for every trinomial, okay, if it's factorable. If the trinomial is factorable, you can use AC grouping every single time, even for problems like this. If your trinomial is factorable, you can use trial and error for every single problem, even like the problems from before. It's just going to determine how long this process takes and how tricky it is. So my advice, use factoring by AC grouping if A is greater than 1. Use trial and error when A is equal to 1. Okay? I promise it's just going to be a lot easier if you do so. All right, go ahead and write down your factored form here. Write down the process. Keep in mind we still went through the whole thing of A times C, finding the combination that gives us B, and then once we have that combination, we can go ahead and just write our factored answer. We do not need to write in, we do not need to rewrite the trinomial as a 4-term polynomial just to make this happen. Okay, I'm going to show you another one. Take a look at 3x squared plus 36x plus 33. Again, our first step, no matter what, is GCF, GCF, right? So we have 3x squared plus 36x plus 33. I hope that 3 is jumping out to you like crazy. So we're going to start off by factoring out the 3. So that, yes, exactly, Kayla. So that leaves us with x squared plus 12x plus 11. So I'm going to go ahead and cover up the 3, just like I have before. Nothing changes. Notice I have a trinomial, and notice my leading coefficient is a 1. So this signifies, trial and error time. Okay? So trial and error time, I go through the same process, A times C. So this is going to be 1 times 11, which is a positive 11. And I want factors of 11 that give me a B of positive 12. That's what I'm looking for. I'm looking for a positive 12 here. So we have 1 times 11, and those are our only factors. Yay, that made life easy. If both of these are positive, they add up to 12, and ta-da, we found our factors. So now, because I'm writing trial and error, I can go right into my factored form. Notice my leading term is x squared. I have to break that into 2 parts evenly, right? So x squared breaks down into x times x. And then I'm going to take the 2 factors that I found, which were a positive 1 and a positive 11, and I'm going to write them directly into each of the separate sets of parentheses. I'm going to lift up my finger. Notice I still have a 3, so I'm going to bring that right down, and my final answer is 3 times x plus 1 times x plus 11. Isn't trial and error great? It's so awesome. Let's turn the page so that you can all try this and see how nice this process is and how quick it is. I love trial and error. Okay. Keep in mind for your notes, you have this sheet in case you want to reread this, if you don't have access to the video. One thing I want to point out is we do not need to rewrite the trinomial as a 4-term polynomial. We do not need to do that. Okay? When we use this process, you don't need to rewrite the trinomial as a 4-term polynomial. You just go right into the actual factored form. Cool. Go ahead and try number 1. We're going to factor completely, and then I'd like you to check your result. I am looking for at least 3 students to submit their solutions to the chat. Give this your best shot. Let's see how you do. Very nice. Let's take a look. I've seen a lot of responses in the chat. Step number 1, GCF. We're going to factor out 2. That leaves us with d squared plus 9d plus 20. As always, double check. 2 times d squared is 2d squared. 2 times a positive 9d is positive 18d. And then 2 times 20 is 40. I'm going to go ahead and cover up my GCF of 2 so that it's not distracting. Notice I have a trinomial whose leading coefficient is 1. So I'm going to go ahead and use trial and error. Trinomial, trial and error. Beautiful. I'm going to run through the process of taking A times C, which is a positive 20, and finding factors that will ultimately give me the combination of, I will combine my factors that will ultimately get me to my B, which is positive 9. So we have 1 times 20, 2 times 10, and we have 4 times 5. Notice that because my 20 is positive and because my B is positive, I know that both of my signs are also positive. So 1 plus 20 is 21, 2 plus 10 is 12, and then 4 plus 5 is 9. And that is the correct pair of factors. So at this point, I'm ready to write my factored form. Notice my first term is d squared. So d times d will give me d squared. And then I have my 2 factors of positive 4 and a positive 5. So I'm going to go ahead and write those inside the sets of parentheses. And of course, reveal my 2, which means it moves right down in front of the sets of parentheses. And there is my factored form. Excellent work, Ryan, Patrick, Cindy, Kayla, Dot, Claire. That is fantastic. That is absolutely fantastic. So as always, you should make sure you check your result. You can distribute your two binomials, so d squared, 5d, 4d plus 20, and then combine those and then distribute the 2 to get 2d squared plus 18d plus 40. Good. I only have 5 minutes left, so I want to run through at least one more problem with you. So we have a negative 5m squared plus 45mn minus 100n squared. As we look at this problem, you know your first step is GCF. So right away you're looking and you're saying, okay, leading negative, that's the first thing. And then you're like, okay, numeric part. 5, 45, 100, well, I know 5 can go into everything. And then variable part, m squared, mn, n squared. Okay, I can't factor out any variable because all three terms do not have the same variable. All right, so my GCF is negative 5, no big deal. Let's factor that out. Negative 5m squared divided by negative 5 is simply m squared. Positive 45mn divided by negative 5 is going to be negative 9mn. Negative 100n squared divided by negative 5 is a positive 20n squared. Okay, notice your variables. I'm going to go ahead and cover up my negative 5, and I'm still going to notice trinomial leading coefficient of 1, trial and error. Write out the technique. Now we have our A and our C, so it's 1 times 20, but you know, similar to our last problem, which is a positive 20, but my goal this time is for B to be negative 9. Okay, so in order to get a negative value, recognize that your factors both have to be negative, right? Because that's how you'll get a positive 20. So we have 1 times 20, both are negative, 2 times 10, both are negative, 4 times 5, both are negative. So negative 1 times a negative 20 is positive 20, and then negative 1 plus negative 20 is negative 21, right? Go through the same process. So this one doesn't work, this one doesn't work, and actually let me cross those out. But when we look at negative 4 times a negative 5 and then negative 4 plus negative 5, that's what gives us negative 9. All right, cool. Now, be very careful when you factor this. Watch what happens. First things first, my leading coefficient is my leading term is m squared. We break down m squared by separating into m times m, right? M times m is m squared. Now we still have our factors negative 4 and negative 5, so negative 4 and negative 5, but there's one more issue. Look at the last term, 20n squared. Well, if for m squared you broke it down and wrote it as your first term in each parentheses, then your n squared you must break it down and write it in your last term or in your second term for each set of parentheses. So your factored form actually looks like m minus 4n times m minus 5n with that negative 5 in front. That is how you will get your n squared, and that is how you will get your mn. So I'm going to do a quick check for you. So let's write check here. Negative 5 times m minus 4n times m minus 5n. Again, I would always distribute your binomials first. M times m is m squared. M times negative 5n is negative 5mn. Negative 4n times m is negative 4mn. And negative 4n times negative 5n is positive 20n squared. You're then going to distribute the negative 5. What I would actually do in this case as well, I would actually combine these two. So we have m squared minus 9mn plus 20n squared. And now I'm going to distribute that negative 5. So we get negative 5m squared, positive 45mn, negative 100n squared. Check. We get exactly the original polynomial. Excellent work. That was fantastic. Keep practicing this technique. Actually, practice all of them. So, for instance, if you're struggling with any particular idea, any particular factoring technique, re-watch the videos. These videos are available for forever, right? As long as I have this page, they're going to be available. So make sure you're watching them so that you understand the process behind it. If you have to watch it a couple times, no big deal. Who cares? And then always practice that process. If you have to, work with some tutors. The Math Learning Center has tutors available. Please check them out. The link is in your Lumen course. You know exactly where it is because it's clearly labeled. Okay? Make sure you're doing your homework. Continue practicing. Have a wonderful weekend, and I will see you all on Monday for week 13. We're almost done. Bye, everyone.